Okay, our next talk will be delivered by Limor and is entitled Compositional Structure Can Emerge Without Generational Transmission.
Okay. Can you hear me? Great. So welcome to today's talk. This is joint work with Shiri Leverie and Antje Meijer at the Max Planck Institute. And just to set the framework, thank you very much for starting with this. What we talk about when we're talking about the emergence of linguistic structure, at least for the purpose of this talk, is I'm going to focus only on the transition from a state of some sort of a holistic proto-language to a state of a full-blown language that looks something like the languages we speak today with systematic structure and grammar. And one of the hallmarks of this transition is claimed to be the emergence of compositional structure. So basically the emergence of some sort of ability to reuse elements in a systematic way to get different types of meanings. And in a recent study in the field, Simon Kirby and colleagues have argued that this compositionality emerges as a trade-off between two forces, expressibility on one side and compressibility on the other hand. And the way this works is the following. So they argue that on one hand you have a pressure for languages to be expressive. This pressure pushes languages to be this maximally informative system. And they argue that it's naturally imposed during communication. So because the goal of communication is to get your message across, to be understood, then the expressivity pressure will emerge during communication. But on the other hand, languages also are pressured to be compressed. So there is another pressure on languages, basically to have some sort of a minimalistic, transparent system with very clear and productive rules that can generalize to an infinite set of meanings. And they argue that this pressure is imposed during transmission to new learners. So because the language is being learned again and again and again, it's pressured to be compressible and learnable and transparent. So when these two forces come together, what we have is basically on one hand a language that needs to be minimalistic and easy, and on the other hand a language that needs to be expressive and full. So basically the solution for this is to develop compositional structure. And the way they do this, as we just seen in laboratory settings, is basically to take the diffusion chain paradigm, introduce communication to it. So we have a dyadic diffusion chain in which a pair of participants come to the lab, they're trained on an artificial language, and after several communication rounds, their language is the input for the next pair. And when you do this for several rounds, what you find is that indeed compositionality emerges. So what I'd like to show you here is that, So there is systematic reuse of elements. So for example, this shape is always marked with ege, and you also have marking for the texture. So for example, wawa for the checkerboard, woo-woo for the dotted ones. So this is a very compositional language. And what I'd like to talk about today in this current study is just to expand on this current framework by focusing on this bit. So what I'd like to argue is that in fact, pressure for compressibility does not necessarily need to arise during transmission to new learners. I would like to say that there are other sources for compressibility pressure rather than generation turnover. In fact, what I'd like to argue is that compressibility can be during communication. So I'm going to try to convince you today that compositional structure can really emerge only in communication alone, as long as the communication includes two features. And these are two real properties of language use, which you find in natural settings and natural environments. So the first thing is if the communication includes talking to multiple people. So when you interact to a lot of people, this holistic supermaximal non-compositional system is kind of hard because you need to converge with a lot of people on it. You have a lot of input variability from all the people you talk with. And we know that when there's a lot of input variability, there's more pressure to overcome it. There's more noise. And indeed, input variability is one of the things that highlights and boosts systematicity. In fact, there are some researchers like Ray and Grice that argue that talking to strangers is one of the driving forces pushing languages to be predictable and structured. So this is one possible source for compressibility pressure that can emerge during communication. The other thing is having some sort of an expanding meaning space. So in the real world, we don't just talk about a closed set of meanings like often done in this artificial language experiments, but really we have more and more things to talk about, sometimes an infinite set, pushing languages to again have some sort of a productive rule that I can use to talk about new and more meanings as they enter the language. Okay, so indeed these two pressures are possible sources for compressibility within communication. So our design, I'm going to show you that we had basically different micro-societies. They were sitting together. We had 3 groups of 4 people. They were sitting together and they were playing a communication game. They were doing this in alternating dyads for different rounds. So what this means is that for the first round, for example, participant A and B were playing together, and C and D were playing together. They were having several games, in this case 23. And after 23 games, they switched. For example, participant A is now playing with D, and B is now playing with C. And then for the next round, they switch again, and we do this for 6 rounds. They were interacting about different novel items that I'll show you in a minute. And importantly, they were doing this using only an artificial language that they come up with together in the first round of the game. So the basic design looked something like this. It's a low-tech pen and paper experiment. So one participant, they were sitting, this is a dyad interaction. There's a barrier between the two. One participant sees an item, and he needs to describe it in this artificial language, or fantasy language, as we called it. And then he shows this word to the other participant. The other participant is faced with a grid, and that has 8 different items, and they can make a selection what they think participant A meant. They can make the right selection and get a point, and the whole point of the game is to get as many points as possible, and we encourage the participants also with an extra prize. But you can also choose the wrong item. But importantly, no matter what you choose, participants get feedback. So participant A knows what participant B selected, and participant B knows what participant A meant. Okay, so they get a chance to improve as the game progresses. So our materials, we had basically a meaning space that had 4 different shapes, and they appeared in different types, in different sizes. So it was a continuous meaning space, not a categorical meaning space. And also each item had a different idiosyncratic feature, texture. So that is, if participants really want to come up with this maximally informative system, they can. Right? It makes sense. And as I explained, this experiment is going to have 2 important features of real communication. One of them is going to be talking to switching partners. So each round, participants switch who they're talking with. And again, the meaning space is expanding. So what this means is that we start out with having just 8 items in the first round, and we add more and more items as the game progresses until ending with 23 items in the last round. Okay, so what did we find? We didn't only look at structure, we looked at various different measures to categorize the system. So I'm going to start by showing you the convergence. I'm going to start by showing you how participants develop a shared lexicon together. So what we're doing, we're measuring the distances between the words produced by different participants for the same item. So how much are they similar to one another? And what we find is that there is, when we put this in a mixed effect model, that there is a significant effect of item's age. So what you see is that as older the item gets in the game, participants agree, the distances between the different labels of participants is reduced. So participants agree on what is the word for that item if it's old in the game. But also we see this interesting interaction with round. So in later rounds, participants actually need less time to converge on a new item. So when a new item enters the language in a late round, participants kind of already agree on what to call it, and this is faster in later rounds. This is supposedly because participants have developed some sort of a predictable, perhaps compositional system that kind of allows them to agree on what the word should look like for a new item even before it enters the language. We also looked at stability. So this is often called learnability in Kirby studies. This is basically the differences, the change in the language over time. It's not an error because there's not a real, there's not a real answer here. There's not a true or false. So we looked at the stability again by looking at the differences in labels across time. And what we see is that there is a marginal effect for items age. This is perhaps a power issue because there are just 3 groups. Every line here is a different group. And then what we see is that older items are basically more stable. They change less as they are older in the game. And again, we find this nice marginal interaction with round, so it matters less and less how old items are as the games progress. Participants have supposedly developed this system that allows them to agree on what the word should look like. Okay, so looking at structure, we measure this by looking at the correlations between meanings and string distances. This gives us an estimate of whether similar meanings are being expressed using similar strings. This is the standard way to look at compositionality here. And what we see is that indeed there is a significant increase in structure over time. And this is true when looking at raw correlations and also when looking at z-scores produced by the Mantel test, which is often the measure given for compositionality in these experiments. And I'd like to give you an example of one such language. So this is a language produced by one participant in the last generation. What you can see is that there is a unique string. The coloring here is just for visualization purposes, had nothing to do with the analysis. It's just to make my life easier and hopefully yours. So what you can see is that there is a unique string that is associated with each of the shapes. And there's also some morphology emerging for size. So it seems like, for example, big items of shape 4 get an additional prefix za, and medium items of shape 4 and 2 get zo. There's also a beginning of perhaps an iconic suffix for something small, ni. But just to set your mind that this is not only based on just three groups. So ever since we submitted the abstract, we already run a new version of this experiment, which is a computerized version. Basically, we changed size into motion. So we had different items, and they were just moving on the screen in different directions instead of being in different sizes. So it also gives this more of an event-like feeling. And indeed, again, with 3 more groups, what we find is that there is a significant increase in structure over time, even to a point of 0.6 correlation, which is quite amazing. And I want to show you an example of how this looks like. Don't be alarmed. Basically, what you can see in this graph, so the different, So the different rays indicate the direction to which the item was going to. And the different box color is a different type of shape. So if you can see, shape 4, no matter where it goes, always gets tawe. Shape 3, no matter where it goes, always gets spunk. And there is also a nice morphology for direction. So what we can see is that everything that's in the top goes up, gets a ho. Everything that goes down gets an u. And there is also some morphology for right and left, which is really interesting. Okay, so indeed we found that compositionality can emerge without generational turnover. And just to conclude, I argued that compressibility pressures can indeed arise from various sources, not just transmission and learning. In fact, I showed you that it can emerge during communication alone, as long as it includes these 2 important features about language use. And the implications here. So for one, this study suggests that compositionality can actually emerge in a communication in a single generation. It may take time to stabilize, and it may take time to expand to other dimensions, but the essence or the seed of compositionality can already be there within a generation. This is relevant for developing sign languages and for creoles, which often have this discussion whether you need a new generation for several things. So at least for the seed of compositional structure, our study suggests that you don't. Okay. And then finally, there is another implication here, and that is perhaps everyday properties of the way people interact and language use can really impose different types of compressibility pressures. So imagine, for example, that cross-cultural differences in interaction patterns or input variability patterns, how many people you interact with, for example, can really bring about different types of pressures and maybe affect linguistic structure. So the reason we've developed this whole paradigm is because we wanted to be able to compare different types of groups. So now in the lab, we're going to look at big groups versus small groups, tightly connected groups versus sparse groups, and so on. So that's it. I'd like to thank everyone who helped programming, helped with coding, gave advice, and so on, and thank you.
2 minutes.
Thank you. This was very interesting. I'm wondering, so you've hypothesized there's these 2 factors that need to be present. Did you manipulate them independently?
So this was done by the original Simon Kirby study in 2015 to basically want to say that if you only have expressivity pressures, then you get a very holistic, super expressive language, but very holistic and hard to learn. On the other hand, if you only have learning, then you get sometimes these very learnable and compressed language.
Sorry,
but
I was unclear. I mean, talking to multiple people and emergence of new meanings.
No, we did these 2 combined. Basically, the point of developing this paradigm was we really wanted to have a design that we can have groups together and look at differences in compositionality without having many people come to the lab, because it's very hard to do with a group of, for example, 8 people. So basically, we wanted to give the optimal conditions for compositionality to emerge, so we didn't.
I just wonder if multiple people would suffice, because I'm not, although meanings expand over development, I don't get a sense that there's that much that, like, once you reach some adult state, I feel like we talk about the same things all the time, as evidenced by very similar themes in literature, like over, many generations. Well, so I'm not sure if that's a
Well, this is a miniature language, right? So
sure.
Yeah, so having only 8 items and not increasing it might not be enough, I think. Yep.
Hi, Christopher Hammerly, Department of Linguistics at UMass Amherst. I'm I want to ask a question about your definition of compositionality. It seems more like what you're referring to as compositionality is more like conjunction rather than what we normally think of as compositionality in semantics, which would be something like saturation of an argument of a function, say verb like runs, where you would saturate the argument of that with John, so John runs. Whereas in this experiment, it seems more like you're getting something like an object is green and an object is big, which isn't the same sort of compositionality in the Fregean sense of the term.
Well, I'm not sure I follow, because so to me, and also in the literature that this cultural evolution literature, the idea is that compositionality is basically the ability to reuse elements. And to do this when you say John and walked, I don't see how that's very
That's not John and walked, it's
sorry.
John, yeah.
Sorry.
Yeah. So it's a broader issue with the use of compositionality in the literature, not just within.
Okay, well, I follow this definition of compositionality. So
But
basically,
anyway.
the difference, it's contrasted with a holistic system.
Right, so I guess what my question would be is, do you have evidence of compositionality, not in the conjunctive sense of like X is green and X is big, but in the sense of...
Yeah, I'm not a semanticist, so I'm not sure I understand this, the subtle difference that you're trying to make. I'm sorry. We can talk about this later, though.
All right,
I'd love
thank
to.
you.
Unfortunately, we're going to have to take it offline again, sorry. We have to move on to our last talk. Thank you, Limor.
Thank you.